Hi everyone, thanks for joining us. My name's Ellie Rennie. I'm a professor at RMIT University, and this is my colleague Kelsie Nabben. We're social scientists, but we're also working with Dr. Michael Zargham from Block Science on this project, who I'm crediting with the technical aspects of what we're about to talk about, and economist Jason Potts, also a distinguished professor at RMIT University. So we know that organisations have knowledge beyond the sum of their individuals. There is an intelligence inside organisations which you can't access unless you are in them. And social science research has been talking about this for some time, as we will go into shortly. We can talk to a representative of an organisation, but it's always partial. So my provocation today is, what if we could talk to Ethereum? And by that, I don't mean talking to Vitalik. It's probably pretty difficult to get a meeting with him for a start. But also, he's only one view into Ethereum. What if we could talk to the whole of Ethereum, to the ecosystem? And what if the sub-organisations within Ethereum could talk directly to each other without needing to go through representatives of those organisations? So at the moment, within Ethereum, the dev teams understand the protocol. We have mechanism designers who understand crypto economics and incentives, how to design tokens. We have DAO stewards and ethnographers such as Kelsie and myself, who know something of communities and the governance aspects of DAOs, the culture. But this is also a research problem. Academics are publishing papers, including ourselves, which at the moment are mostly being consumed by ChatGPT to intermediate to other humans. And while that is not necessarily a bad thing, I think it probably increases our knowledge generally, but it is occurring without the context that's held within knowledge clubs, within scientific organisations, to be known. And that might be things like the updated data that it's drawing on, or the methodologies and why they matter, connection to other work, when we're accessing those publications and papers through AI. We think it's pretty rudimentary at the moment. So the structure of this talk is we're going to start with a very brief account of the theory that Jason's been doing. We'll run through the infrastructure that Block Science is building and why we as ethnographers are studying it and why we think it matters, and also how we are actually using it.
I'll take this one, thanks. So in terms of the old theory of the firm, the way that it's typically thought about in the blockchain context is that the firm is there to reduce transaction costs to enable coordination. We're focusing on this project on a slightly different theory of the firm coming from Penrose, which is that firms organise, deploy and recombine internal knowledge as a dynamic knowledge-based entity. And so this has been developed by a number of other theorists within institutional economics, but we're specifically focused on that knowledge. And as Ellie said, the knowledge as organised by a firm is more than the sum of its parts. So firms can do things like the example that Professor Jason Potts provides is, firms can build an aeroplane, but no one person within a firm can do that or can even explain how that is done. And so the point here being that the firm is a knowledge-bearing, transaction-managing institution, and the knowledge within an organisation is very difficult to organise and compute over. So it's distributed in all different ways, stored in all different databases and so forth. And although many large firms have knowledge management systems, this does still not create or convey the intelligence within the firm. So the new theory of the firm, our hypothesis, is that through computational knowledge organisation infrastructure, and we'll explain a specific protocol called COI, which is being built and experimented with, although there's a number of versions of what this could look like. So through this COI, we can build the loop to connect knowledge processing with governance and production. So now we're not just looking at the Kelsian firm or the Penrose firm, but we're actually combining this loop of knowledge and production for the greater than the sum of its parts value that the organisation holds. And so in the words of Jason Potts, now humans can talk to organisations and organisations can talk to each other. And this is something that has been called in an early post by a partner on the project, Michael Zargam, knowledge networks. And so this is when organisations are able, through this computational infrastructure, to communicate. I think I've got this one as well.
I think you do.
So like I said, it's our hypothesis. The actual infrastructure involves large language models and AI agents, giving an organisation the ability to query itself. So this is improving the organisation's legibility to itself and to other organisations. It enables those infrastructuring the COI loop to set the context, so the agents have to abide by rules, standards and specifications, which is different to AI performing a particular service or deploying an AI agent for a particular purpose. And so our hypothesis again is that COI is this missing piece, referred to in some of our research data as the duct tape, that enables knowledge networks, keeps provenance and enhances governance while context remains intact. So to apply this theory to the old DAO as an example, so operations in the DAO, in the typical instantiation that we've seen it, they occur often by an external professional team bidding to run a specific operational function of a DAO, or through a sub-DAO, which is organised under the umbrella of a DAO. And often, we've seen many cases of DAOs where the founder is unable to step out of the DAO. Examples in my mind where founders have stepped back in, after trying to leave to ensure the organisation remains on track and aligned with its purpose. We know that governance occurs through distributed knowledge, which is held across GitHub repos, forums, social media, blogs, etc. And that significant time can be taken in the case of a contentious vote. So I think of a specific FIP in Filecoin that I was part of the research team, and I know Block Science was engaged on that to help make sense of the facts. So they needed expert engineering to help make sense of the facts around a specific vote, because there was kind of misinformation and disinformation and contention around the decision that should be made in that particular case. And so it's very difficult for any one DAO participant to have the attention to actually understand all of what's happening across a DAO, and then to be able to analyse that to make an informed decision when it comes to governance. Next slide, please. And so when we apply this COI infrastructure in theory, this artificially organisational intelligent DAO, it already contains the machine-readable traces because it's a digital-first organisation needed to compute over the firm. And what this could mean is that operationally, the organisation has knowledge sensors, which Ellie will explain the technical details of in a second, but it's able to know and coordinate what's happening across the governance and operational layers. And so what this creates in the diagram here is a version of Stafford Beer's viable system model. So it's a more cybernetic organisation that can sense itself and then actuate or create the ability to make informed decisions over the information contained within the organisation. Ellie.
So when we're talking about these infrastructures, I should just preface it by saying there's a decentralisation of production that's occurring across, say, in Ethereum, these different sub-organisations, nodes. And there is governance, we're including that within our infrastructure. And then there is this architecture and protocol, which is COI itself. So a key component of knowledge organisation infrastructure, as Block Science is building it, is what they call reference identifiers. So these are essentially like library call numbers, which is different to the book itself, but it's a thing that enables you to locate the book. So an RID is able to differentiate the reference from the referent. So the description of that book from the book itself. Why these matter is that we're able to communicate about an organisation's knowledge through these reference identifiers without necessarily granting access to the inner workings of that organisation. So two organisations can in fact be referencing the same knowledge sets or knowledge objects, but they can have different RIDs for that, so they're describing different ways in which they're governing or using those knowledge objects, which enables a plurality. It enables diversity, different perspectives on the same thing, which we think is important. So we can share also through RIDs what we know without having to conform to any centralised system and put all of our information into the same software as a service product. And so groups just go about doing their own thing. In the case of DAOs, managing that knowledge and data. And there are sensors that are picking up on that, assembling it into collections and making it available. And this is, as I have here, it's governance aware. So the community can set priorities around what they want to be done with that particular knowledge set, including for AIs and agents, and they can define rules at the node level. And multiple communities could even agree across themselves to use the same rules, right? So that's where you have this kind of network nations model occurring. The nodes themselves will talk about RIDs. They perform 4 different functions. They listen, they make external calls, they can broadcast messages, respond to queries. And I'm drawing all this from Michael Zargham's talks and published works. They effectively interact in a pseudo-social manner with other Koi nodes. And what occurs here is that these nodes are able to also be sensors to be able to pull, say, data if they've been permissioned to. So very quickly, how we've been using it. So as I mentioned, we're ethnographers, so we work with qualitative data. And we're using Koi to be able to effectively perform certain, to create knowledge collections and perform a kind of management over workflows and how they're accessed. So a few years ago, we created a bot with MetaGov, which is called Telescope, which you can put into a Discord server. It will ask the author, if a telescope emoji is put on someone's post, the bot will ask the author for permission to include that in a qualitative data set and send them some information about the project. And this was all fine, except it's still going into probably a private database of some kind where the ethnographer is actually then trying to analyse and make sense of that. And so I started working with Obsidian and creating an Obsidian template and vaults to be able to do that. And then we realised that actually Koi is very useful for then being able to take that context, those links, the field notes, everything that not just me, but multiple ethnographers or community members may be adding to those individual posts to be able to provide a much richer context and data sets. And then we effectively, through an Obsidian plugin that we built, which is a processor node, we were able to push that back to, in this case, MetaGov itself, which is where we're experimenting with this particular Koi instance and array. So the way we talk about this is that, in effect, rather than putting humans in the loop, the ethnographers in this case are actually building the loop. We're creating that workflow, which then an AI agent may be useful, or LLM of some sort, to be able to provide access to real-time data sets that community members, say in a DAO or some decentralized network like MetaGov, can query to understand better what's occurring with that richer context. This is a little diagram by Luke Miller, our developer, which just shows how those nodes fit together in this particular example that I'm talking about, where telescope is the sensor node, and how we have a coordinator that can facilitate node discovery. We can put permissions, for instance, around how that data is then distributed to different researchers or back to the community. And the community might also put rules around the data set itself too. And that's really in this project, MetaGov's role is to consider what kind of governance tools are required for using this technology effectively. So where
Ellie,
to from
could you
here?
go into some of the possible, so that's telescope's one example of a COI application.
Yep.
What are some examples that would apply to a DAO or Ethereum as a whole?
Well, this particular example I've given, you could easily see how that might be used within a DAO, as in community members themselves could use something like Telescope to signal things which are important for a particular topic or thread or conversation that's occurring, and to add that additional context which you're not going to get just by scraping channels and putting an agent or LLM over that to enact something. So it could be, so our particular example could be used in a very, very direct way by DAOs, and we're hoping that might occur in the future. And Telescope itself could become more agentic, where it's also going out and helping find things which are relevant to the questions you're asking. So this is very early stages. Block Science does have a dedicated, super smart team working on this. MetaGov doesn't really have the resources to be creating the governance tools and usability that we'd like to be doing yet. So we are still seeking funding on both sides for that work to continue and occur. So please reach out if you're interested. Thank you. Yeah, there's a question here.
Yeah, thank you very much for this presentation. Very interesting topic. My question is about the next steps. So, for instance, we have an organization, we have like this digital artifacts of its work, either its on-chain activity or like, I don't know, history of the chats and etc. What could be the steps for implementing this framework? So what are like the first steps to sort of onboard the organization into this approach?
Well, it would be a matter at the moment of implementing the COI architecture itself, which we need more people working on that to make it more usable. There's a very cool demo up on the Block Science website where they used MCP to kind of self-assemble a COI network, which is worth checking out. But yeah, so I think that once that's done, then there are all these more, I suppose, social questions around how the community makes decisions around what knowledge sets are in the COI, how those, what kinds of permissions and boundaries are put around them. You could start to use this for contributions and attributions, even if you're using your RIDs effectively, which might enable a kind of far richer ability to understand who and how the DAO evolves. Well, how the DAO evolves through whom. Yeah.
Thank you.
You can add.
Yeah, so another way of saying that in terms of implementation is that it's in the process of being productized by Block Science, although it's an internally funded project for them. And the source code is open source on GitHub, but it's not like a plug and play application at present.
Telescope's also open source on MetaGov.
How is COI dealing with ambiguity? So if you get different contradicting informations?
I think maybe that's an empirical question we still need to research and understand. I mean, it's probably, in this case, the ambiguity is that you might have different RIDs, different descriptors on the same knowledge object. I think, if anything, it probably enables, like, real ambiguity that exists in the world. Would you agree with that? Yeah. Yeah, the world is ambiguous. Yeah. So hopefully it enables us to accept and navigate ambiguity. Yeah.
All right, thank you very much.
Thank you.